Yes, in this section, I'll be presenting the project Open Metadata Enriched non-proprietary data format for data dissemination. And I'll start with a basic introduction to the project, including the problem statement and our mission in the project. And this will be followed by concrete work components, specification, and import filter that we are currently doing, and to give you a concrete idea about our work. And hopefully from there, we can open the discussion, and I'll be very glad to receive your comments and suggestions. So about the project is a part of the Consult SWD, which is a big collaborative consortium with more than 30 research data centers involved across in Germany. And the overall mission of the Consult SWD is to support research data management for social and behavioral sciences in all phases of the research data lifecycle. It is also in the structure of the German national research data infrastructure. So our project is located in a social economic panel at DIW Berlin. So why we want to develop an open data format? When we take a quick look at the current data dissemination project, we will find out that majority of data research centers provide data in the formats based on the popular statistical software packages, such as SPSS, Stata, and SAS. These statistical softwares enable a combination of data and metadata and provide a well-developed analysis environment for researchers. However, they are proprietary data format, and users need to buy the license for using them. For data itself, there are formats such as DTA and CSV files that are commonly used, but it doesn't make much sense to have the data alone without metadata. And for the metadata, there are a lot of work have been done, and a variety of formats of metadata is available, such as XML, CSV, and PDF files. And there are also online metadata portals where the users can browse the data catalog. So from the quick summary of the current data dissemination practices, we identified some problems. First of all, the proprietary data formats that are commonly used undermine the principle of FIRE, and it is not in line with open science. And in order to reach a larger use base, the data providers often provide data in a variety of formats, leading to increased costs. And when it comes to data format conversion, many data providers are doing duplicate work. Another aspect is different data formats, which are only partially compatible, represent an obstacle for replication studies and data reuse. And the last point is for the documentation and metadata that are available in PDF document or in online-based portal. To use this additional information, the researchers have to leave their familiar software environment, and which makes the analysis inconvenient. So to address these problems, we aim to specify a non-proprietary open data format. And what do we mean by open data format? It is, on the one hand, enriched with metadata that describe the dataset with different level of information. And the open data format is a combination of metadata and data. There are several candidates of the data formats based on which we would like to build our own data formats, such as metadata in CSV, or XM file, or data in CSV or DTA file. It is still ongoing discussion, but we are currently using CSV files for our internal data format. And on the other hand, our project is not only about specifying an open data format, but also to provide a support for technical implementation in different statistical software programs. That means the open data format should be easily operated in the popular statistical programs. So from the overall mission of the project, we decomposed our goal into several specific working components. The first task is to specify and document a metadata schema. It is a central work throughout the whole project, and we will start from an expandable minimum specification and keep developing it into a well-structured schema. The second aspect of our work is to develop technical implementation. Is to develop a conversion filter with which proprietary data formats can be converted into the specified metadata schema, and to develop import filters for the commonly used statistical programs so that the specified metadata can be used for dataset labeling and dataset management. So this slide gives a more intuitive demonstration and mapping of our tasks. In the center is the internal data format. It is where the specification work actually happens. And based on the specification, we test the import filter and conversion filter functions for the statistical programs on the right side. The software that we currently have in mind are Stata, R, and Python. The small red arrows indicate the tools that we attempt to use to realize the functions. And on the left side, it is where we try to make our data format compatible with existing widely used metadata standards, especially EDDI families. So that's basically the whole map of our work in the project. And I'll keep using this map as a navigation in the following part so we won't get lost. So now, from the overview of the project and the mapping of the work components, I will narrow it down to more specific and concrete work areas. Our work starts with a minimum specification of a metadata schema. The internal data contains a variable CSV file and a variable category CSV file. We combine the metadata with a simple data CSV file from SERP. In this way, it will be our very preliminary open data format. Now we take a further look in the package. On the top left, it is a variable CSV file which contains metadata information at variable level. As you can see, so far there's only a limited number of description areas for the variables, and we'll keep working on it and enriching it. So for the multilingual feature, we keep it with us at the very beginning. So we have for all variable both English and German labels. Below the variable CSV file, it is a variable category file, which contains information of value labels, called specification. And on the right side, we have the raw data. So overall, it's a simple structure, but it still contains basic connections. For example, for the variable BAK sex column, we can find the information about the variable and value labels in the metadata files. And based on this schema, we have explored a new feature for the variable metadata, and namely the URL column, which is a URL pointing to a specific variable page in the online metadata portal. In this way, we hope to link the two forms of data publishing and provide end users with more information. So let's take the example of the variable BAK6. There is an external web page where the user can get more illustrative and connected explanation of metadata based on the work that have already been done in the research data center. So the scenario will be that the user don't have to take additional time to find more information for their data sets. The online metadata platform will be integrated in the data package published by the research data center. So now let's move to the compatibility with external metadata schema. For the metadata specification, we have already have the awareness that we should make it compatible with DDI families. And we currently explore the DDI codebook and try to map the schema to our internal specification and generate DDI codebook, a sample DDI codebook in XML format. And here we would like to discuss with the community and get some suggestions about how we can efficiently make our data compatible with CDI. And since DDI, CDI is also getting in the shape, so we would like to know about the new features of DDI and what issues might occur additionally when we trying to integrate DDI, CDI in comparison with the DDI codebook. So any opinions will be welcome, very welcome later in the discussion. Away from the specification, we have also done some work in the technical implementation, and I'll give short introduction of our work based on Python and R. So based on the three CSV files, as I showed, to read the internal format in pandas, and users will be able to query any variable information, and also the code specification for the variables. And they can also view the raw data version and labeled data version in Python. And as I mentioned before, like we keep the feature of multilingual language at the variable level in the very beginning of our specification work. Now for the implementation for the multilingual metadata tags, it is now also possible to query the metadata value labels in the desired language and view the different language versions of the data. So for now, the minimal format we have, there will be 3 available data versions: raw data, English labeled, and German labeled data. So we'll continue to develop the filters, and eventually we hope that the import filters will make the analysis easier for the researchers. Another import filter is also under developing for R. So we have tested some functions for the data, such as load the data in R and do some simple operations such as count and generation diagrams. The labeled version of the raw data will be also available for users. And we'll keep developing this import filter for R, and we hope eventually it will be possible for users to use the function embedded in R to do further analysis with our open data format. So for the URL feature that I introduced before, we implemented it in the user interface in R, and it will be possible for users to directly open the link of the variables, and then they will be guided to the target web page to gain more relevant information online.
You have 5 more minutes.
So yeah, that's basically yes, thank you. that's basically all the map of our work, and we are now end of the journey of the introduction. And for the future work, like I mentioned before, we would like to talk with the DDI community to get more suggestions about how we can efficiently make our data compatible with DDI. And since also a lot of people working on the DDI CDI, we would also like to know what new features of DDI CDN and what issues might occur when we also want to integrate DDI CDI into our metadata schema. Yeah. Okay, that's all for my